So, welcome to the solutions video for our Pythagorean identities in CK12.org's trigonometry section. So there are three main Pythagorean identities. There's sine squared plus cos squared equals 1. If we divide both of those by cos squared, we get 1 plus tan squared equals secant squared. If we divide them instead by sine squared, we get 1 plus cotan squared as cosecant squared. So there's no manipulation necessary. It is simply secant squared. Now if we multiply this out, it's a little more complicated. We'll have 1 minus cos squared plus cotan squared minus cos squared cotan squared. So cotangent is cos over sine. 1 minus cos squared is sine squared. That'll be simpler than multiplying it out. So sine squared times 1 plus cos squared over sine squared works out to sine squared plus cos squared. That's 1. Again, cotan is cosine over sine. So this is 1 minus cos squared over sine squared. Well, 1 minus cos squared is sine squared. Sine squared over sine squared is 1. 1 minus sine squared is cosine squared. Cosine squared times secant squared is 1. Now 1 plus cotan squared is cosecant squared. Cosecant squared is 1 over sine squared. So if cos squared plus sine squared plus 1, 1 plus 1 is 2. Now given that angle x is in quadrant 4, and that sine of x is a negative 4 over 5, determine the value of cosine of x. Now, if this is in quadrant 4, that means our cosine is positive. So we can either take our calculator, do the inverse sine and then the cosine, and convert the angle it gives us to put it in quadrant 4. Or we can use our Pythagorean identities to say a triangle with sides 3, 4, and 5 is a right triangle, so our adjacent side would have to be 3 if our opposite is 4 and our hypotenuse is 5. This is a ratio. We don't know exactly it's 4 over 5. It could be 8 over 10. It could be 12 over 15, but we know it'll fit those proportions. So tan is sine over cos. So this becomes sine squared over cos. Putting it over a common denominator, we have sine squared plus cosine squared all over cos. 1 over cosine is secant x. And I didn't mean to hit the caps lock. So if we're in quadrant 1, secant is 1 over cos. So cosine is 1/3. But we're looking for tan. So we want 1 plus tan squared is secant squared. So 1 plus tan squared is 9. That means tan squared is 8. Square root of 8 is 2 root 2. Here, if cosine is 3/5, and we have cotan squared minus 1. Okay, so I would say if cosine of A is 3/5, then that means the secant of A is 5/3. And 1 plus tan squared is secant squared. So tan squared is secant squared minus 1. So 5/3 squared is 25 over 9. We subtract 1. Okay, let's go to the scratch pad for this. So if cos A is 3/5, we could also say that sine A is 4/5, because cos A is 3/5. So the tan A, well technically this is plus or minus, but then tan A is plus or minus 4 over 3. So cotan A is plus or minus 3 over 4. We don't know whether it's positive or negative, but we have the squared. So cotan squared 4 times cotan a squared minus 1 is 4 times 9 over 16 minus 1. So that's 9 over 4 minus 1. That's 5 over 4. So here we've got cosecant plus cotangent. And this is one we have to watch. So cosecant squared is 1 plus cotangent squared. So that means cotan squared is cosecant squared minus 1. So cosecant squared would be 9 over 4. We subtract 1, we get 5 over 4. So 9 over 4 plus 5 over 4 gives us 14 over 4. We then multiply it by 4, we get 14. And finally, cos over sine plus sine over cos. That's what we're dealing with here. So let's try this in the scratch pad. Cos over sine plus sine over cos. But because the skill is specifically in the Pythagorean identities, I'm going to try putting it over a common denominator of tan. That'll work much better. Our tan plus tan is a tan squared, and 1 plus tan squared we know is secant squared. Now tan is sine over cos, so when you have it in the denominator we get cos over sine. Secant is cosine squared. One of these cosines cancels, so we end up with 1 over sine x cos x. That's A. Okay. So the memory boost questions, I think we need to be working with the system a little bit longer for those to work. So memory boost questions, I think, are pulling in content from previous lessons that we were struggling with. And remember, your teacher cannot see your answers unless you turn them in. So always, always, always hit that turn in button.